Welcome back everyone. Just going to get into two slightly more complicated or potentially slightly more complicated questions using integration by substitution. So in this first question, what I'm going to do to begin with, to make the problem a little bit more recognizable, is I'm going to just complete the square in the denominator. So that is the integral of 2 over x squared plus 2x plus 1 minus 1 plus 6, and make sure to write the dx on the end there. That's going to give the integral of 2 over x plus 1 all squared, and then also plus 5 dx. Now I can make my substitution. So let u equal x plus 1. This means that du dx just equals 1, which actually means that du equals dx. So that being the case, I'll make my substitutions back into the rule now. So it's the integral of 2 over u squared plus 5 du. Now this looks quite similar to the antiderivative that gives the inverse tan function. So the problem is that I need this number here in the numerator to be a square root 5 for that to work. So to begin with, what I'm going to do is I'm going to just move that 2 outside the integral, because I can move it through like that, and that leaves with 1 over u squared plus 5 du. Now, as I said, I want that numerator to be a root 5. So to do that, well, I can actually just make it a root 5. But the thing is that I have to do something to counter that, and so at the front I'm also going to have to divide by the square root of 5. And well, this should give us everything that we need here now. So the integral in this case is going to be 2 on root 5 inverse tan of u on root 5 and then plus c, and we make our original substitution back into this. So we end up with 2 on root 5 inverse tan, and u we said was x plus 1. And there we have it. Now, for the second question, what I'm going to do here is I'm going to make u equal x plus 3, which means that du dx also equals 1, which means that du equals dx. So subbing this in, now to make life a little bit easier, something else I can do is from this line right here, I can actually rearrange this equation to say x equals u minus 3. So now I'm going to make this substitution back into the original problem. So I'm going to have 2 lots of x, which we said is u minus 3, plus 4, and then I've also got u to the power of 20 dx. Oh, whoops, we said that dx was du, so I can just make that du straight away. And if I go through and simplify this a little bit, I'm going to have 2u minus 6 plus 4, so that makes minus 2 times u to the 20 du, which I can expand that out now to give 2u to the 21 minus 2u to the 20 du. Oh, this hasn't worked out too badly. So anti-differentiating this, we'll get 2u to the power of 22 over 22, which just becomes u to the power of 22 over 11 when we simplify it, and then minus 2u to the 21 over 21 plus c. And so the last thing is to make the substitution back. We said u was x plus 3, and so we end up with x plus 3 to the power of 22 over 11, and then minus 2 times x plus 3 to the power of 21 over 21 and plus c. So there we have it. I'm going to do one final video which will do a definite integral, so I'll see you there.